the other topic I'm going to explain about is oxidation and reduction reactions. Oxidation and reduction reactions easily are known as redox reactions. They had a definition, they have an old or traditional definition. The oxidation reaction, old definition is that it is the addition of oxygen and the removal of hydrogen, while in reduction, the traditional definition is that the removal of oxygen and the addition of hydrogen. They define it like this because it's because oxygen was the only or the first oxidizing agent to be known by chemists at that time. For example, if we look at carbon reacting with oxygen, it gives carbon dioxide. The reaction is already balanced. When we look at the oxidation number of carbon, it's 0. The oxidation number of oxygen is 0 because they exist as an elemental form. This is one of the rules of oxidation number. And the other thing is here, the oxygen has -2 oxidation number. Oxygen has -2 oxidation number, except in peroxide, superoxide, and with fluorine it has +2 oxidation number. With in peroxide it has -1/2, and in superoxide it has -1 in peroxide, -1/2 in superoxide. Here oxygen has -2, and -2 times 2 is -4. So we all know that in a neutral compound, the addition of oxidation numbers is 0, so carbon must have an oxidation number of +4. So they thought that when carbon reacts with oxygen, they call this oxidation. The addition of oxygen causes the carbon to get oxidized because its oxidation number increased from 0 to +4. And when we come to reduction, let's say nitrogen reacts with hydrogen to give ammonia. Here the chemical reaction is not balanced, so let's use inspection meter to balance it. Here we have 2 nitrogen, here we have 1. We add 2 here. This is a coefficient which is written in front of formulas and symbols, it's a number. So we have 2 nitrogen, but we have 6 hydrogen, so we add 3 here. So when we look at this reaction, we say that an elemental form, the oxidation number or state is 0. That when the compound is formed, there's also a rule of oxidation state about hydrogen. The oxidation state of hydrogen is +1 with metals, while it's -1 with metals. This is +1. So this is +3. So nitrogen is -3. So they thought that the oxidation number of nitrogen decreased from 0 to -3. So the hydrogen or the addition of hydrogen was caused for the reduction. That's why they defined oxidation and reduction in this method. But the modern or the real definition of oxidation and reduction is that oxidation is the loss of electron, while reduction is the gain of electron. We define oxidation and reduction based on the transfer of electron. And when we look at this example, this may be sodium. So when sodium reacts with chlorine, it gives sodium chloride. Here, 2 processes have occurred. These are reduction reaction and oxidation reaction. Here, sodium has an oxidation number of 0, while chlorine has an oxidation number of 0. And here, sodium lost 1 electron. So we say that loss of electron is oxidation. And when an element loses an electron, its oxidation state increases. So it becomes +1, while chlorine gains 1 electron that has been lost by sodium, so it becomes -1. So here we can see that sodium got oxidized, which means increased in oxidation number, while chlorine got reduced, which means it gained an electron. These 2 terms may be kind of confusing. For example, here sodium got oxidized, so it's a reducing agent. While here, chlorine gained an electron, so it got reduced, so it's an oxidizing agent. we say that sodium is not a reducing agent because it is the cause for the reduction of chlorine. We say that chlorine got reduced by gaining this electron. So who released this electron or who donated this electron? Sodium, right? So if sodium donated this electron, then it is the cause for the reduction of chlorine. That's why we call it a reducing agent. While chlorine is the one who accepted that the electron that has been lost by sodium. So it's an oxidizing agent, which is the cause for the oxidation of sodium. So this is all about oxidation and reduction. When we come to percentage composition of elements, here we can see the molecular formula of, let's say, a compound containing elements A, B, C, and with their subscripts X, Y, Z. So if we want to find the percentage composition of one of the elements, we can calculate it by dividing the molar mass of one of these elements by the molar mass of the whole compound and multiplying it by 100%. This will give us the percentage composition of that element in the compound. For example, calcium phosphate. Calcium has a valence of 2, while phosphate has -3, so crisscross, let me do this. If we want to find the percentage composition of, let's say, phosphorus, we make the percentage composition of phosphorus is equal to the molar mass of phosphorus over the molar mass of the whole compound. So the molar mass of phosphorus is 2 times the molecular mass of phosphorus, which is 31. 31 times 2 is 62, divided by calcium has a molecular mass of 40. A molar mass of 40. 40 times 3 is 120. 120 plus phosphorus has 61 molar mass here, and 8 times 16 is 128. So this would result in 62 over 310 times 100%, which will give us 20% or something like that. So we can find the percentage composition of any element in a compound by using this formula. The mass of the element in 1 mole of a compound divided by the molar mass of the compound times 100%. So this is all about the percentage composition of an element in a compound.